Hello. Today I'm going to explain the structure of a neuron and how neural transmission works. Using my neuron model. In this model, the dendrites are represented by a PlayStation Vita, the soma, or cell body, is represented by a battery, the axon is represented by a phone charger, the terminal buttons are represented by an Atari console, and the synapse is represented by the end of the phone charger connection. A neuron is a specialized nerve cell that sends information throughout the body. First, let's talk about the dendrites. The dendrites are represented by the phone. Dendrites receive incoming messages from other neurons and carry those signals toward the cell body. They act like antennas that collect information from nearby neurons. Next is the soma, or cell body, represented by the battery. The soma contains the nucleus and keeps the neuron alive and functioning. It also processes incoming signals. The battery represents energy because the soma provides the support and energy needed for the neuron to work. The axon is represented by the phone charger cable. The axon carries electrical impulses away from the soma and toward the terminal buttons. Its job is to transmit information over long distances within the nervous system. The terminal buttons are represented by the Atari 2600. These structures store and release neurotransmitters, which are chemicals that send messages to the next neuron. Finally, the synapse is represented by the end connection of the charger. The synapse is the tiny gap between neurons where neurotransmitters travel to continue the message. Now I'll explain the process of neural transmission. When a neuron is not sending a signal, it is in a state called the resting potential. During resting potential, the neuron has a negative charge inside compared to the outside. The neuron is basically waiting for a message. When the dendrites receive enough stimulation, the signal moves to the soma. If the signal reaches the required threshold, the neuron fires an action potential. An action potential is the electrical impulse that travels down the axon. In this model, the signal would move from the PlayStation Vita to the battery and then down the charger cable. This process follows the all or none principle. That means the neuron either fires completely or it does not fire at all. There are no partial action potentials. Inside the neuron, sodium ions move into the cell, making the inside more positive. Then potassium ions move out to restore the negative charge. These changes in electrical charge allow the action potential to travel down the axon. When the action potential reaches the terminal buttons, neurotransmitters are released into the synapse. These chemicals cross the gap and bind to receptors on the next neuron's dendrites, continuing the message. So overall, each structure has an important role. The dendrites receive information, the soma processes the signal, the axon carries the electrical impulse, the terminal buttons release neurotransmitters, and the synapse allows communication between neurons. This model helps demonstrate how neurons rapidly communicate throughout the nervous system to control thoughts, movement, senses, and behavior. Thank you for watching my presentation.